So in today's lesson, we're going to be learning about how to derive an equation for a circle with the center at the origin, in other words, at 0, 0. So the way that we're going to do this is we're going to employ some ideas from our length of the line segment, which is the previous lesson. So I want you to envision that we have, essentially, we have a point plotted at the origin, and we have a second point plotted somewhere out here, and we're going to label our origin as x1, y1, and we're going to label this point that's somewhere out as x2, y2. And then what we're going to do is we're going to draw a circle around such that that line becomes the radius of the circle with its center at 0, 0. Well, what do we know so far? Well, so far we know that we can calculate the length of that line, which is essentially, by the way, the radius of the circle, by thinking about these coordinates as being formed by a right-angled triangle, with our horizontal distance representing our change in x and our vertical distance as our change in y. And thinking about this as a right-angled triangle and using Pythagorean theorem. So we can develop an equation for that circle in terms of the radius and those coordinates by saying, well, the radius squared is going to be equal to, because remember that radius is representing the hypotenuse in our right-angled triangle. So our radius squared is going to be equal to our change in x squared plus our change in y squared. Not so different from our length of the line segment. If we wanted to expand this, we could also write it as x2 minus x1, showing the coordinates, plus y2 minus y1 all squared. I forgot the squared there. There we go. And so there, we've derived the equation of a circle with the center at 0, 0. So we know if the center is at 0, 0, then x1, y1 are always going to be 0 and 0. So I'm going to go ahead and I'm going to substitute those in. So r squared is equal to x2 minus 0 squared plus y2 minus 0 squared. And that gives us x2 squared plus y2 squared. Now, often what they'll show you in textbooks is they'll say, well, we know that the other point is the origin, so let's not worry about it calling the second point point 2, because point 1 is always the origin. And so they'll typically write it with just x squared and y squared, knowing that the coordinates x and y, the x and y representing one particular coordinate on the radius or on the circumference of that circle. All right, so there, that is the equation of a circle. Let's move on and try some examples to help you know how to use this tool. We're going to start with a relatively easy example. Example 1 here says, find an equation for a circle with the center 0, 0 and the radius 4. So the radius is 4, so I can write that out as a given, r equals 4. And I know my general equation is r squared equals x squared plus y squared. So all I'm going to do is simply substitute in r equals 4 for r, and then I'm pretty much done once I simplify. So 4 squared is equal to x squared plus y squared. So my equation for my circle in this case is 16 is equal to x squared plus y squared. Now often you'll see that just sort of rearranged as x squared plus y squared equals 16, just putting the variables first. But it's not, that's just a point of convention, not really a big deal. Okay, let's take a look at a second example. All right, so I should point out that example number 1 and example number 2 are fairly straightforward examples. They would be what I would consider to be baseline examples, and we're going to look at a couple more that will ask a little bit more of you. So hopefully by building these smaller skills, you'll be able to manage the leap to the harder question. So in example number 2, it says, Determine the radius of a circle with an equation this, right? Now, I'm going to point out a couple of common mistakes that I see once we work through this. So I know that the generic or general equation for a circle is always x squared plus y squared equals r squared. Now, given this, that must mean, therefore, since my x plus y is equal to x plus y, that r squared must be equal to 81. That's what that is really saying, right? So r squared, if r squared is 81, then I know that I can get the value of r by simply taking the square root. And so r is going to be equal to plus or minus 9. But in the context of this question, the radius is going to be the positive value because it's representing a length. Okay, so now it doesn't give us any values for units, so we can simply write units if we want to. Another thing I should mention, the most common mistake I see is students wanting to jump to the answer, and they will immediately say that, oh, the radius is 81. Forgetting that it's x squared plus y squared equals r squared and not r. So just be aware of that. It's a common mistake I see, and hopefully by having this discussion, you'll be able to remember not to do that. Let's look at a third example. This one's a bit of a step up, but I think you'll manage just fine. Okay, so example number 3 has 2 components. It says determine an equation for a circle that has its center at the origin. That's all we know how to do this year. And passes through the point a, 6, and -8. Okay, so that's part A of this question. Part B says, is the point B, -5 and 9, inside the circle? Right, so here's what we're going to do. We're going to just block off part B of this because we don't need to deal with that right now. So let's just make a space to tackle A, and then we'll get to B later. So what I tend to do is I go back to, well, what is the general formula of an equation of a circle? And as we've just seen, we know that r squared is equal to x squared plus y squared. And so a good place to start is to say, remember, I know that this coordinate a6 -8 is actually an xy coordinate. And so if my equation holds true, I should be able to substitute those values in if indeed A is a point on that circle, right? And that's what it must mean, is that it's on the circumference of the circle. So I'm going to go ahead and substitute in that value, those values for x and y into my existing formula and see where I go. So I'm going to go 6 squared plus -8 all squared. And now I'm just going to clean this up. And I get that r squared is equal to 100. Right? And so now I could go ahead and say, okay, well, that means that r is going to be the square root of 100, which I know is 10. But remember that my formula actually asks for r squared. So I'm probably best, I don't really need to figure out what the square root of r is. I know that it's going to be 10, but I need the 100 to sub into my equation. And so I can go ahead now and finally get the equation of my circle. That 100 is equal to, x squared plus y squared, right? Because my r squared is actually 100. So there I've solved the equation for my circle. I don't think that was too taxing. Let's take a look at the second half of this question. So the second part of this question, just to remind you, we want to know if this point B, -5 and 9 is inside the circle. So how are we going to decide that? Well, remember that we have an equation for a circle, and if we wanted to mock this up, we could say, all right, well, I have a circle. This is obviously going to be pretty rudimentary because I'm not using any special tools here. But, I know right now that my radius really is just the distance from the origin out. So no matter where I go, that distance from the origin, if I had drawn this really nicely, should be 10. And why am I saying that should be 10? Because, again, remember that r squared is equal to 100, and that means that my radius is actually 10 units, right? So if I measured the distance, the length of the line from my origin at 0 and 0, all the way to this point right here, be -5 and 9, and I determined how the length of that segment, right? So from my origin to that, if it is exactly 10, then it lies on the circle. If it's less than 10, then it's inside the circle, and if that length is greater than 10, then it's going to be outside the circle. So let's just do that. And if you're not quite with me yet, that's okay. We'll just keep working at it. So right now, I want to know the length of the origin, or the length from the origin, which I'm going to label O, which is at 0, 0, all the way to this point B, -5 and 9. I want to know the length of OB. So the length of OB is going to be equal to, remember my length of a line equation, x2 minus x1 all squared, plus y2 minus y1 all squared. Now, because one of my points is in the origin, that actually makes this pretty straightforward. So I'm going to go -5 minus 0 squared and 9 minus 0 squared. Cleaning all this work up. So -5 all squared plus 9 all squared. So I'm getting that OB is root 106. And, so OB, the length of OB is going to be the root 106, which I know is going to be larger than 10. Yeah, it's 10.3. So that tells me that OB, the length of OB, is 10.3 units long. And my radius, the radius of the circle, is 10 units, right? So what this is telling me is that since the distance from O to B is longer than 10, longer than the radius, that the answer to my question is the point inside the circle. The answer is no, it's not. It's going to be outside the circle, and that is because the length of OB is longer than my radius. Okay, so that is it for today's lesson. I'm going to assign you a few questions to help you practice this skill. You can see how it's really just using the length of the line idea, extending it to the equation of a circle, and then using it to solve some problems. And I should point out that you will see this again at the very beginning of grade 11 functions when they ask you about domain and range of various functions. One of the functions will be that of a circle. So this will help you in that capacity as well. As always, reach out with any questions, and I'm happy to help however I can.